Welcome students. In the last module we had talked about the non-conventional sources of the energy. In this module we shall learn about the energies from the sea, that is the tidal energy, wave energy and the ocean thermal energy. The next, that is the geothermal energy. The next one being the nuclear energy, and the last two topics, that is the environmental consequences and how long will an energy source last us. We shall also talk about the advantages and the disadvantages caused by the tidal and the wave energy. We'll also watch the inbound videos of the tidal wave and the ocean thermal energy, and by which means the electricity is being produced, and also by the geothermal energy as well as the nuclear energy children. Due to the gravitational pull of the moon on the spinning earth, the level of the water in the sea rises and falls. So if you live near the sea or ever to travel at some place near the sea, you have seen how the sea level changes during the day and the night. Now this phenomena is known as the tidal energy. Now this tidal energy is being caused by the differences of the tides, and it is being harnessed by constructing the dams near the shores. And as the changes of the tides takes place, the rotation of the turbine takes place. Now as the rotation of the turbine takes place, these turbines, they convert the kinetic energy into, we can say, the electrical energy children. Now let us see the schematic diagram of the tidal energy, how the electricity is being produced, children. Now as you can see in the diagram, children, there are the sluice gates in the water basin, and once the water enters, the sluice gates rise up, leading to the movement of the water from high to low, we can say, reservoirs. And after that the turbines rotate and the electricity is being produced. Now let us watch a video so that you get the clear idea of this picture of the tidal energy.
So what do you think this is? It looks like windmill, but actually it's a tidal turbine. Its working is simple, just spin its rotors to produce huge amount of electricity. So how to make it rotate? Thanks to the gravitational forces exerted by the sun and the moon, which causes natural tides and rotates the tidal turbine. This rotation rotates the generator and produces electricity. Then through the power lines, electricity reaches our grid stations and homes. Similarly, these big machines are also tidal turbines. Having these machines working underwater, you can get lots of clean energy. This turbine produces electricity enough for 1,500 homes. And this for 1,800 homes. And this for 1,500 homes. Well, tidal power is so beneficial because it produces free and clean energy, as no fuel is needed and no waste byproducts are produced. It's not expensive to operate and maintain as compared to other forms of renewable energies. As of now, high and low tides can be predicted in advance. It is a highly predictable energy source. It works underwater and so less noise pollution. However, adoption of tidal technologies is very low as compared to other renewable sources due to site requirements. Additionally, tidal plants can only be installed along coastlines. I think we should go renewable to save the planet from global warming. That's tidal power. Let's go renewable.
As you have seen in the video, you might be clear with the working of the tidal energy. But let us talk about the advantages and the disadvantages. The advantages are that once the dam is built, the tidal power is cheap. You can get the energy at a lower cost. There are no greenhouse gases or any other gases produced by the tidal energy. It also facilitates a predictable amount of energy. That is how the tides is being caused and how much amount of energy is being produced. But at the same time, the disadvantages are that the majority of the power dam are very expensive to build across the sea. In order to for a project to be successful, there must be a high tidal range. Now, if there is no high tidal range, it is of no use to them. And maintenance of this tidal energy facility can be difficult because it is located in the seashore and in the oceans, children. Now, let us move on to a new topic, that is the wave energy, children. Now, we have seen the tidal energy and the production of electricity through it. Now, let us study about the wave energy. Now, it is similar to somewhat the tidal energy, children, but in the wave energy, the kinetic energy produced by the waves near the sea, they are being trapped in the similar manner by the so as to same with the tidal energy, and these waves are being used to generate the electricity. Now, the kinetic energy is being converted into the electrical energy by rotating turbines. Now, these turbines, now how do they rotate? They rotate due to the movement of the waves being caused on the offshore. Now, you know that how do the waves are being caused? Now, these waves are being caused due to the difference of the gravitational pull and the wind of the air that is being caused by, and for that the energy is being produced, children. Now, let us talk about the production of the wave energy, children. Just look into the diagram. Now, if you look carefully, the waves are being created by the wind, which in turn is caused by the sun. Now, this makes wave energy a light more to use. Now, the light which is being flashing beacon on the top of the device is used to protect the ship. Now, as the floaters, they move on the surface up and down, it causes the waves. Now, these magnets which you see down, they are being moving up and down with the waves inside the generator. Now, the generator coil, what it does, the electric current is being induced in the coil and the magnets move up and down. Now, these magnets which move up and down, they are being secured by anchor to the seabed, and now from the seabed through the electric cables, the electric current is being passed on, and this electric cables, they take the energy into the power stations for storage, children. Now, but let us again talk about the advantages and disadvantages of the wind energy. The advantages are that they are renewable, they are environmental friendly as they do not release any gases or any harmful or chemicals in the air. They are abundantly and widely available on the offshores, and there are variety of the ways to harness this wave energy because of the generation of the crest and the trough, that is the waves, and they are easily predictable that in what time, what kind or what type of waves they are being out to produced. But the disadvantages, that is, they are being only confined to certain locations, that is near the sea. Now, they are being having an effect on the marine ecosystem, and for other one, there is the source of disturbance for private and commercial vessels also, that is the ships. Now, OTEC, that is oceanic thermal energy conversion. I talked to you about that. It is not in your syllabus, but I'm a bit sorry, children. Now, the basic difference in the temperature is exploited to obtain the energy in ocean thermal energy conversion plants. Now, the surface temperature difference is about 20 degrees centigrade or 20 Kelvin or more. Now, the warm surface water is used to boil a volatile liquid like ammonia. Now, these vapors of the liquid are then used to run the turbine of a generator, and the cold water from the depth of the ocean is pumped again and condenses the vapor again, that is the ammonia, to the liquid ammonia, we can say. Now, this energy potential from the sea is quite large, but efficient commercial exploitation of this OTEC is quite difficult, children. Now, how does it take place? Let us understand through a diagram and the video as well, children. Now, as you can see in the diagram, children, first of all, the water at the surface, it has a high temperature, like we can say 40 degrees centigrade. It is used to heat up the liquid ammonia, and liquid ammonia vaporizes, and this vapor in turn what you can say, moves the turbine. Now, this turbine, the cold water at the bottom, it condenses the liquid ammonia into the water again. So therein, the liquid ammonia can be used again and again. Now let us watch through a video, children.
Did you know that we can use the natural temperature differences in oceans to produce clean electricity, day and night, and all year round? This is called ocean thermal energy conversion, or OTEC. It works best in the tropical equatorial zone. Here, the ocean temperature difference is at least 20 degrees Celsius throughout the year. How does it work? The ocean's warm surface water vaporizes a working fluid with a low boiling point, ammonia for example. The vapor expands and spins a turbine that is coupled to a generator that produces electricity. The vapor is then cooled by cold deep seawater. That way, the working fluid condenses back into a liquid and you can reuse it. This makes it a continuous electricity generating cycle.
Now, the geothermal energy. See, the magma of the earth heats up the bed on which the groundwater is present. So, the heat of this magma generates the steam at high pressure, and this high pressure steam is released through springs. Springs means a collection of the water beds at the near your house or all the other places where there is volcanic activity, eruptions taking place. Now, this steam is used to rotate the turbines, that is the kinetic energy which is being produced, and these turbines, these rotating turbines, they generate the what, children? The electricity. Now, the production cost of this geothermal energy is not much, but it's efficient also. Now look at the video, children, of the geothermal energy.
Geothermal. Geothermal refers to producing energy from the internal heat of the Earth. The internal heat of the Earth is generated from radioactive decay of minerals and continual heat loss from the Earth's original formation. Geothermal wells are drilled into the Earth's crust at approximately a depth of 3 to 10 kilometers. The heat is extracted with a variety of methods, but in most cases is drawn from the Earth using water and steam. Hot water from the Earth may be directly extracted to heat homes and buildings. This is done either by directly circulating the hot water through buildings or by pumping it through a heat exchanger that transfers the heat to the building. Geothermal heat can also be used to produce electricity in a geothermal power plant. Electricity is generated when geothermal heat produces steam that turns turbines on a generator. The major regions of geothermal development are in the most volcanically and tectonically active regions of the world. Though geothermal energy is currently a small player in the world's energy mix, one of its key advantages is its reliability and consistent power generation, which means it can provide baseload electricity. Concerns with geothermal include the accidental release of CO2 and hydrogen sulfide emissions stored in the Earth's groundwater that is often used to carry geothermal heat to the Earth's surface. Additionally, drawing heat from the Earth's crust can, if done irresponsibly, lower the ground temperature below the surface. The upfront costs for geothermal energy production are relatively high. It is expensive to carry out the seismic sensing, test well drilling, confirmation testing, and other necessary preliminary investigations to ensure that your new geothermal plant will be capable of meeting desired production. That's geothermal.
Now, the next topic, that is the nuclear energy. Now, in the beginning of the chapter, I told about there are two types of nuclear energy reactions that are going on. There is the fusion and the fission. Now, let us talk about the fusion, children. Now, in the fusion, what happens is that the small isotopes of the hydrogen, like deuterium and the tritium, that is H2 and H3, are being fused together to form a large amount of energy. Now, with this energy, helium, that is the He2, are being produced and a large amount of neutrons are being released. Now, how does it take place? That is, with the interconversion of this energy, children, a large amount of energy is being produced. Now, you can think that you can say an amount of uranium can produce 10 million times the energy produced by one atom of carbon from the coal, children. So, can you imagine how does it take place? Now the next is the nuclear fusion. Fusion meaning to break. Now in this, generally the uranium, that is the element 235 or 238, is being taken with the neutron. Now this neutron is being bombarded to the uranium, and this uranium splits into two or more neutrons, and the neutrons releases the what, children? The heat energy, and in turn these neutrons, they bombard with the other uranium and release an tremendous amount of energy. Now this chain reaction causes a large amount of release of the energy, children. But if we talk about the other side of this nuclear energy, it is very, very dangerous, as the waste produced by the nuclear fission and the fusion, they are, we can say, dangerous, as they causes the cancers in the human beings. They are carcinogens, children, and the radioactive radiations which are being passed by these reactions are very, very harmful, children. So it is not advisable to use this type of energy, children. Now we look at the video for this, children.
Nuclear energy. Nuclear energy is the energy held in the nucleus of an atom. It can be obtained by two types of reactions: fission and fusion. Nuclear fission produces energy through the splitting of atoms, which releases heat energy that can be harnessed to produce electricity. The fuel most commonly used for nuclear fission is uranium. However, other elements such as plutonium and thorium can also be used. All of today's operating nuclear plants use nuclear fission to generate electricity. The second type of nuclear energy is nuclear fusion, the same process that powers our sun. Fusion is a nuclear reaction in which atomic nuclei collide at a high speed and join to form a new type of atomic nucleus. During this process, matter is not conserved because some of the matter of the fusing nuclei is converted to photons, which produces energy. Fusion power offers the prospect of an almost inexhaustible source of energy. However, creating the conditions for nuclear fusion presents a potentially insurmountable scientific and engineering challenge. A recent experiment has shown that nuclear fusion can be achieved. However, it has not yet been successfully demonstrated on a commercial scale. Today, nuclear power plants account for 11% of global electricity generation, with about 80% of that installed capacity being in OECD countries. All of this capacity is nuclear fission. Nuclear energy, through fission, can release 1 million times more energy per atom than fossil fuels. Nuclear plants have large power generating capacity and low operating costs, making it ideal for baseload generation. Because of its large scale and centralized nature, it can easily be integrated into electricity grids, requiring few changes to existing infrastructure. However, upfront capital costs are intensive and present financial risks to investors given the long time frames power plants must operate to recover these costs. Nuclear energy does not emit greenhouse gas emissions. For this reason, it is often seen as a substitute for fossil fuel electricity and a solution for mitigating climate change. However, nuclear power holds a wide variety of environmental and health issues. The largest concern is the generation of radioactive wastes such as uranium mill tailings, spent reactor fuel, and other radioactive wastes. Some of these materials can remain radioactive and hazardous to human health and the environment for thousands of years. Several nuclear accidents in recent history have negatively impacted the environment and surrounding communities, making nuclear power a controversial topic for the general public. That's nuclear energy.
Now, the last topic, that is the environmental consequences. Up till now, we have seen how the energy is being obtained by the conventional and the non-conventional modes of the energy, and how they are being used, the advantages, disadvantages. Now, exploitation of any energy depends upon three things. That is the ease of extracting energy, that is how much easy is for us to extract that energy, the efficiency of the technology available, meaning through which modes of the technology we can avail this sources of the energy, and the environmental damage that is being caused by using that energy, children. Now, it depends upon how do we use that energy. Like if we use the nuclear fission, of course it can yield much more amount of energy than the carbon atoms and the coal, but we cannot use it because of the environmental radiations that they cause. Now, up till how much do we have to lose this energy? That is till the future generations, and we have to save it for the future generation, children, and for that we need to save this energy. Now this is all about this chapter, children, and I hope you are clear all with this chapter and the topics, children. Thanks for watching this video and all the videos that you have watched so far. Thank you very much, children.